So that particular question, you want to pass by many steps because they say analyze, right? Analyze. Analyze in order to graph it, in order to sketch, you want to pass by all they mentioned, information, pertinent, even. Anyhow, so let's make the plan. You should mention domain. You go by the basic to the more advanced, let's say, discussion, analyze domain, and then you want to do the intercepts. The order is not important, but this is the perfect representation. Then you want to go with the asymptotes. These are the information needed. Then you do the derivative and you make a table discussing the behavior. Increase, make a table or make line representation or whatever. Okay. Increase, decrease, maximum, minimum that you mentioned, local extrema. Okay. Maximum, minimum. This is what you want to study. And then you do the second derivative. You want to study concavity and inflection. That's it. And then based on all those, you're able to sketch or graph. Then you graph. So you want to pass by all these steps. So the function is 2x minus 1 over x squared. I want to keep it in mind. Equal 2x minus 1 over x squared. So let's start. Domain. What is your domain?
Equal to 0, so x can't be 0.
Not 0. Okay. The domain means if in a fraction you don't accept the 0. So it's every possible value, but not a 0. Because if it is a 0, we don't have a value for y. So the domain is where the values, where are the values of x accepted, or your continuity. So it's continuous everywhere except on 0. Now you can say x not 0. In a interval notation, not 0 means minus infinity to 0, union 0. So we don't take the 0. So that or, okay, you present it either this way or that way. They prefer interval notation. Okay. So this is step 1. Step 2, you want to find if they exist, the intercepts. How do you find intercepts? Now, x-intercept, if you want to identify, and the y-intercept, if they exist. Okay, we don't know. X-intercept happens when y equals 0. That happens when x equals 0. Okay. Now we are saying here x cannot be 0. How it comes that you put x 0? So x 0 cannot, because if you put x 0 again, you get minus 1 over 0. So there's no. We say there is no y-intercept. It means no y-intercept. Now you are showing, okay, if that you know, you want to just mention that none. Some would say none, or no y-intercept, or you want to show how did you get it. Okay. You may. Okay, now for x-intercept, what do? Put y0. If you put y0, you want to solve for x. So if you cross multiply, you get the numerator to be 0, so x would be half. So it passes by x equal half. That means the point half y0 is your intercept point. Good?
Yeah.
Okay, next we do what? We do asymptotes. Now, asymptotes, we have in your course so far, we discussed only 2, vertical, horizontal. So vertical, horizontal. Again, you may have, you may not have, but you are checking. Again, your function is 2x minus 1 over x squared. Okay. So tell me, do you have vertical? And why? Let's say. We have vertical asymptote for sure, because in vertical, you look at the bottom and you take all to the bottom to be 0. In this case, I have only x squared to be 0, so it means x equals 0. So this is a vertical line, a standing line, which is asymptote. It means the y-axis itself when we graph it, okay? Because x equals 0 means you don't go left, you don't go right. x1 you go right, x minus 1 you go left. x0 means you do nothing. So it's y-axis itself, okay? Horizontal asymptotes, we do the limit as x goes to plus minus infinity, okay? And then this would be the y value. So the horizontal asymptote is a line, y equal. If you do the limit of this, what do you get? There are many ways to approach or find. We said we divide by the highest exponent, right? If we divide by x squared, what do I get? We get 2x over x squared minus 1 over x squared over x squared. And we are doing the limit like this. Okay. We said those they match would stay. Those that don't match would go on to 0. So this is a 0, that is a 0. So you get 0 over 1, which is a 0. Y equals 0 is a horizontal asymptote. Here, x equals 0 horizontal asymptote. Okay? What is y equals 0? So this is your axis. Later on, we want to graph it. Y equal 1, you go up 1 unit. Y equal minus, you go 1 unit down. Y equals 0, you don't go anywhere. So it's exactly your x-axis. You get it? This is exactly the y-axis if you want to graph it. Any question?
No. But can we graph it?
Yeah, at the end. We cannot graph now. So yeah, graphing comes at the end. Yeah, for sure. We can graph because this is a problem. We are passing by all steps. We are able to do. So we are done with these. Now the basic and the most important information to graph are those right here, y prime, y double prime. So if you do the derivative, what do you get? Okay. So we have y equal to x minus 1 over x squared. Okay. Now step number 4, right? Okay, find y prime and make a discussion. So this is quotient rule, right?
Yeah.
Prime v minus over v squared. Now some would simplify this, derive it, but that is very rare to happen. Okay, it's up to you. Do whatever you like. We are after what? The critical values, because we want to set y prime equals 0 later. So
Yeah.
do the quotient rule. What do you get?
We get
So
2
this is a u, that is a v.
squared minus 2x.
2 times x squared. Driving to x is a 2 times this, you get to x squared back, all right? The derivative of the 1 is a 0. So this is u prime v done. U prime v, finish. Minus, the derivative of the x squared is a 2x times the 1 up. Over this squared, okay?
Yeah.
Okay, so simplify. Now, simplification is essential. Usually in all derivative questions, we don't simplify, we leave it. But right here it is essential that you continue because you want to find x that makes your derivative either 0 or undefined. But anyhow, let us continue on. So that I should FOIL it. I would get 2x squared minus 4x squared plus 2x. Okay? Over how much?
X to the
X
power
to the
4.
4. 2 is a 4.
Yeah.
Okay, simplify more.
A power raised to a power, they're multiplied, right?
Yes, yeah, we multiply. But here, if you think about adding, multiplying, it will be the same. It's not tricky. But yeah, we multiply. So this is y prime equals, subtracting those. Okay, I am done with that. And you should simplify more because you have x can be taken as a factor. And even the 2, but no need to take the 2. You know? This would be minus 2x squared plus 2. The x squared becomes an x, right? Over x to the 4. So I have taken x from each factor. Now x up and x to the 4, x up, x down can cancel 1. This would be 3 left. So we have minus 2x plus 2 is my final derivative. Is it okay?
Yeah.
Okay, now what comes next? You want to find the critical values and the non-critical values. We have critical and no critical values here, or not critical. We call them partition values. Because by definition, when you have a fraction, that can be, so let me push it to make discussion. So it's not moving, I will move it. Plus 2 over x cubed, okay? This is my derivative. Now the discussion comes on. Well, if that is your derivative, you put it to 0, you solve it. But when you have a fraction, you consider again the denominator. So you solve, we say we solve the upper part to 0 and we solve the lower part to 0. You get it? So if that is not there, okay, that I would solve. If there's a fraction, you would solve the bottom as well, separately. If
I
you
don't
don't,
understand.
yeah, if you don't take this into consideration, your answer is wrong, by the way. It is missing information. It's up to the one who's marking how much he would consider, okay? But that is essential in your study. If you don't take it, it means you missed a lot. So if you take the upper part, solve it, this would lead to critical values, yes. Okay, solve it, you take this to the kick it, you get x how much? X equal 1. We say is a critical value. What do we mean by critical value? It means that the maximum minimum, okay, would exist on those critical values. Now that x cubed would lead to a value, but that already is done. X equals 0 is done from the top, is an asymptote, but to be considered. X cubed equals 0 when you put cube root on both sides, so you get x equals 0. Okay?
Didn't you know that x can't equal to 0?
Yes. Yeah, we are saying x equals 0. We want to mention what does that mean? It means this is a partition value. This is a partition. Partition in a sense, it exists as an asymptote. I mean, this is by the way we explain. Now, is a partition which is out of the domain again. Now, in our example, it is out of domain. Out of domain is the restriction taken. I mean, this is all explanation for you. Okay, is a partition value out of domain. It is not included, so x not 0, but you still put it on the discussion. So the discussion now goes, some would do those on a table representation, some would do it on a number line. I guess your teacher would go on a number line usually. I put the critical value and the value obtained from the bottom on one line, in order even. So the 0 and the 1. Now the 0 is not, see, we scratch it. Scratch it in a sense, it is an asymptote, just for you to not to mess up, okay? So it means no maximum minimum happens here, okay? But critical values admit the maximum minimum later, we'll check. Anyhow, what comes next is you want to fill right here with the plus and the minus. How do you fill in? You pick, you test, we say those are testing points. You pick numbers in this region, that, okay? Or intervals. Go ahead, pick any number that you wish. So -1 can be there. I can pick 0.5 here, and I can pick a 2 there, okay? So those are on circles, we say, in circles, we say these are testing values in your y primes in order to see if this is a plus or a minus, leading to a plus or a minus, okay? So use calculator. That is not being smart. Use calculator. Plug in a -1 here. What do we get in total? So I get a minus, okay? And this is a plus and that is a minus. Do you agree?
Yeah.
That you can figure out. So the minus means an arrow down. This is arrow up, this is arrow down. So when you go down up, then there's a minimum, right? But that, be careful, this is scratched here, okay? It means no minimum here, none. There's nothing here, none. No maximum, no minimum. Although it looks, but it is not. Even if you do a mistake and you say there is a minimum, it looks minimum. Even, so I want to say minimum, no. There's no minimum there. It looks, but even if by mistake you say this is minimum, minimum has to be a point. And for x equals 0, you go up to replace it. You don't have a value. If you go up, replace here x0, there's no value here, you said. There won't be a value. So you notice that this is not a minimum. But that makes confusion for students. That's what students are confused about, and they lose confidence in the test. You get it? Why we have to understand what's going on. You get it? Any question? The 0 is not a minimum, because that makes confusion. Oh, we learned that this means a minimum. Okay, I have it. Why it is not a minimum? Because that is assigned before or studied. You see, it's out of domain. It's kicked out from the beginning, but it pops in our calculation, yes, because you should assign that to be asymptote. You can say here it's asymptote vertical. It means we don't doesn't admit a maximum minimum, but we take it into consideration that in our graph it exists. This is a study of behavior. What we are doing here on the number line is study of behavior. Some represent in a table, which is much better. So it is clear that this is not taken, for example. You get it? Any question? Good. So
Yes.
there's no here contradiction because students, oh, they say there's a contradiction in our work, and that makes in the test no confidence and errors would start to pop. Okay.
Yeah.
Everything now looks fine. Now this is a maximum for sure because we understand from the beginning that the critical value admits maximum minimum. We expect that to happen, and that we expect from the beginning that nothing happens on this as a maximum because it are values that pop from the denominator. Okay? Anyhow, so that is a maximum. Yeah, it admits a maximum here. Yes. But this is x equal 1 is where the maximum happens. Now, as a point, you should find right now. So the maximum point has an x1. How much is your y is when you replace the 1 in your function. So what is your y, by the way? It was 2x over, or 1, 2x minus 1 over. Okay. So you want to replace 1 here to get your y. How much would be? Simply would be 1 over 1, which is 1, okay? So the point 1, 1 is your maximum point. Maximum point, okay? That you should determine at this point. Because when you reach to sketch, you need a point to plot. You cannot plot x equal 1 only. You want to plot a point. You get it? So it's the time right here to figure out. Okay, we are done with all. We studied all. Now increase, decrease, you can write for sure. Or even you don't write anyhow, but you can write if you want to say increasing interval, decreasing, you should specify, I prefer, because those questions may only be, write your increasing interval. So how do you write your increasing interval? It's only one interval that is increasing, is it? It's right here. So it's from 0 to 1. You don't include the 0.5, right? Are you following? No?
Zero.
Tell me the decreasing interval. What do you write?
If infinity 0,
Minus
union,
infinity to 0, and then
union,
from
1.
1 to infinity. So because we have many numbers, students are sometimes by mistake, so they pick the one in the blue. The blue numbers are testing numbers just to tell my derivative sign, up or down, plus or minus. So right here, either we put a union or a comma. Yeah, but we prefer a union. That's it. Everything is mentioned for y prime. Now we should jump to y double prime. But we jump from the start, which is y prime, which is y prime here. Let me copy it down. So what makes your problem lengthy, because your given function is a fraction, and when you do derive, the fractions remain. The fraction still on, and it pops more and more. Okay. So this is my y prime. I need to start from that expression to get y double prime. Again, it's a quotient rule. Again, if you wanna, some students would simplify this and figure out the derivative, blah blah blah. Find next step is okay, but this is the proper way we do it usually. Okay. So go ahead. What would be your second derivative on? So let me go faster. That would be minus 2x cubed. You know, derivative of this times that. So stop me if you have any question. Deriving x cubed is, but there's a minus, so minus 3x squared times. Now you wanna square the cube, okay? Good. Let me go faster. Y double prime equals. Now that you should simplify. Minus minus plus 6x to the 3 minus 6x squared over those you multiply 3 times 2, 6. Okay. Okay, which ones I am able to add, subtract? Those I'm able. Same, let's say, same x power 3. It is same term. So x cubed 6 minus 2 you get 4. There are many details here. You can jump at any moment. Now you can take a common factor numbers and an axis. I can take x squared. I can keep the numbers. Don't worry. So this is an x minus 6. Any question?
Yeah.
Okay. Because you should simplify. Now the x squared with the 6, you get a 4 left. So this is your final look for the second derivative. Do you agree? Okay, now as we did in y prime, we do in y double prime. So again, I want to study this by itself and that by itself. That would lead to x not 0, yes, I know, but that is in your study. You should include in your study. It's not like something you reject. That for x minus 6 leads to how much? It would lead to x equal 6 over 4, which is 3 over 2. Now that is critical as well. Critical is critical in a sense it admits no more maximum minimum. It's about inflection here. We are studying inflection concavity now. Again, we put the number line and I have two values as well. Again, you pick testing numbers, but that would lead to, so that you can take, now I can figure out easily that this would be, okay? You can take numbers, let's say -1, test it, okay? Take here, let's say 1, you can test, you can take a 2 test. So you see, if you put it opposite, so the root opposite, same sign. Now, yeah, that is should be minuses as well. Okay. Okay, if you put a 1, you get negative. If you put a 2, you get positive, and that is negative. Yes, it's true. So no more arrows. It's about concavity. So this is concave down, down, up. Again, at 0, you should scratch it. Just for you, even the one who's marking, even in books, they put this as scratch. They put it this way. Yeah. It means it's an asymptote. Okay. Anyhow, so here no inflection for sure, but there's an inflection there. Yes, there's an inflection point, and the point should be determined. Now x is 3 over 2. Plug it back. How much was my y? 2x minus 1 over x squared.
Scratch on 0 because it's an asymptote or because the domain doesn't equal 0?
The domain x not 0. It means x equals 0 is an asymptote. The domain is x not 0.
That's why we don't include it.
Yeah, that's why we exclude or reject. And this means take, don't take. Okay. Now put 3 over 2 right here. What do you get? Use calculator anyhow. So you get 2 over 9 over 4. So it's 8 over 9. So that is the point 8 over 9. You agree? Okay. That you can calculate. To show that step. Okay, I am done. So you can say concave up intervals, concave up. Where does it happen? It happens after 3 over 2. And then concave down, it happens in 2 intervals. 0 should be a separation so that we cannot put it in 1. Okay, so it's minus infinity to 0, union 0 to 3 over 2. Any question? Is it clear? Perfect. Okay, now inflection you mentioned, it's already written here, inflection point. Now, if you want to graph it, you put all the information you obtained in one graph and you want to make sense. So the asymptotes are right here, or that's very special. This is the x equals 0 asymptote. That is the y equals 0 asymptote. Now asymptotes vertical, it means it comes the graph, it doesn't touch, it doesn't cross, it comes and says, oh, I would go on parallel to it. You get it? This is the meaning of the asymptote vertical. So asymptote horizontal, it depends on the intercept, but this is asymptote horizontal. Let's say it comes from here or it goes there, okay? Or it comes the touching here or it comes touching there. I mean parallel to it. Make sense? This is the meaning of asymptote. Now,
vertical asymptote is x.
Yeah, vertical asymptote, x equal, imagine x equal 2. So you put a 2 and you make a line standing. This is x equal 2 vertical. For example, x equal -4. This is x minus 4. Okay, because x you go left or right. If y equal 2, for example, you go 2, you make a line horizontal. y2, this is a line y2, horizontal. Okay. Now here we have special asymptotes. You don't go left, right, or even you don't go up or down. So they are the axes themselves. Any question? I plotted the asymptotes, okay, or graph them. Now the maximum point we said it's 1, 1. Now you make your graph. So this is 1 unit in real, okay, but you cannot make your graph so small. I mean, you just say this is my graph. Doesn't make sense, okay? Teachers would not like such a scenario. You make your zoom on clear. Even you don't have that much big numbers. You see 3/2, 8/9, it's nothing. So this is my 1, for example. This is my 1, okay, I'm talking about. So this is a 1, 1. You say this is the maximum point. The inflection is 3/2, 8/9. 3/2 is like 1.5. 8/9, it's something like there. Anyhow, you're right, this is inflection. Now you are not like strict to it, okay? You may erase it, put it properly because the graph should look proper, okay? It's not like graph line, you are not restricted to the point. At the end, the graph should be proper looking. You should manage because you don't have a sketching paper, okay? You should make your graph proper and you put the points accordingly, okay? And you don't show even numbers of it. Just you put a 1. No need like to show, oh, this is like 0.5. If you go 5, you don't say 1, 2, 3, 4, 5. No need. Okay? We don't have sketching paper here. So we jump to the point and the position right away. So what do you graph? You graph asymptote. What is possible to graph? Okay, so the asymptotes are graphable, the maximum or minimum, and the inflection, yes. Now that's it. This is done. I am done. Okay, now you go to your table of the derivative to see the behavior. So I am falling down, you see. Here I'm falling down, then going up, then falling down. You see, this is what you take into consideration. So do you have any idea how to graph it? Now the trick in graphing that you should, because students don't know how to graph in math, we go from left to right in graphing, okay? So when I say a line dropping, I cannot say this is dropping. This is not a dropping line, okay? Is it good? That is not a dropping line because some say, oh, I drop it this way. No, we graph from left to right. Now we are starting right to left. This is wrong way to graph in math. In math, we go from left to right in graphing, okay? From left to right. When I say I'm, let's say, rising up, this is the way I rise up. Falling down, this is the way I fall down. From left to right, I'm falling down, okay? This is how you interpret. Is it good?
Okay.
Okay, now, so go ahead. I am just following the first derivative. Where is it? Asymptotes. I'm here. So I'm falling down, going up. Now, do we have intercepts? Yes. So be careful. The intercept is so important. I am passing by the point half is 0, x half y 0. So where's x half y 0? So this is, I'm passing by this point, by the way. I would pass by. Now you can cross a horizontal, yes, but at infinity it is horizontal, okay? So before the 0, so you see, what does this tell you? See, the graphing needs many, explanation. It tells you before the 0, I am falling down, finish. So I'm falling down. How do you fall down? You come from asymptote to asymptote, you see? You cannot fall down this way because there's no point here. Okay, and this is the falling down. It should be something like this. So how do you fall down? You go from asymptote to asymptote. So it is this exactly representation. This is the exact representation of falling down. That's it. This is done. So this is the left part is done, finished. Now what happens from 0 to, I'm following the table or the representation. From 0 to 1, I'm going up and then I would fall down. I would go up to the maximum, fall down. Okay, but I would pause. You see, it makes sense. I would go up, fall down. So this is the way I would go up, fall down. So you see, now I'm graphing by hand, so you don't have any tools. So you try to pass. Now, if the point is not nice, you move it. I mean, this is my maximum. No one would tell you this is not a 1. Okay, there's no scale, no sketching, sketch paper. You say this is my 1. No one would say why. You get it? And right here, I should pass it by half. Okay, now this is my half. No one would ask me. Okay, no one would ask me. Okay, you get it? Now the idea is it should look nice. It should look like a graph. Now this is a graph. Okay, now I'm passing it now. You see, I'm adjusting on purpose. just to see how you adjust. This is the 1 now for me. This is the 0.5. Any question? You get it?
I'm wondering why is the graphs not connected?
Not connected. It shouldn't be connected. This is a vertical asymptote. How do you connect a vertical asymptote? If you connect, then you don't have any understanding what is an asymptote then. The asymptote is a line takes function to infinity. We don't touch. It's something that burns your hand if you touch it. No way you can touch the asymptote vertical. What do you mean? We are wandering? You shouldn't wander. Asymptote means you don't touch if it is vertical. In horizontal, you can touch, but at infinity, you don't touch even. That's what I want to ask you. How do you go down? You don't touch this. We go to the inflection. So this is the inflection. You see, the inflection is somewhere here. So you come down. You are supposed to come down, but the inflection turns it somewhere else. You see many expansion happening in the graphing. This is the graph. This is the inflection, exactly inflection, because you're supposed to go down, but the point inflection says, wait, you cannot touch this long border. This is a border. An asymptote is a huge border. You cannot cross. So that cannot cross. It goes, it changes direction, we say. The graph changes direction. You see, and right here, you don't cross. So you go here half, you go to the maximum, you go down, you're supposed to go down, but no, this is maximum guaranteed. But you want to go down, but you cannot touch your asymptote horizontal here because there's only one touch there. So you should flip, but redirect direction changed. The direction change is your inflection. And it makes sense. This is like 3/2. It's 1.5 exactly there. That's it. Any question? So, and it goes to infinity. That's it. So the graph is something like this, and then it goes up, and then that is the graph without the system.